Hi everybody. Again, this is an animation that is showing what happens when the Earth is going around the sun. So this is showing it from outer space. So it's as if we're standing outside of the orbit of the Earth. The Earth is spinning on its axis, and sorry, my computer seems to be running a little slow, but the Earth is spinning on its axis, and if I try to speed it up a little bit, you'll get to see it spinning. That's rotation, right? And as it revolves around the sun. So you should have already answered the first three questions before you watched the animation with that was asking you about rotation and revolution. But what I'd like you to look at now is this goes around. You can see this is just each day going by, or it's not actually each day, but the what's happening to the sun as it rises and sets, and the Earth is going around the sun here. And what I'd like you to try and see is what happens to the temperature as the Earth goes around the sun. So that's question number four. See if you can see, here's your temperature over here. It looks pretty clear to me that as the Earth goes around the sun, it's straight up and down. There's no tilt to its axis. As it goes around, there's really no change. So there's no change in the seasons because we're not tilted. We're still revolving, but there's just no tilt on the axis, so there's no seasons. Now, if you look as when I make this go to the Earth's tilt, we can start to see some changes happening now. And the little X here, you can see the little X popping up, is just where our location is. So it's about where we are on the Earth. And as we go around, you can see that the Earth's tilted towards the sun here. The northern hemisphere is tilted towards the sun, and as you can see, the temperature was warmer. And as we move over here into into autumn, the temperatures are getting cooler. We're getting into winter, and we're tilted the northern hemisphere now. This is the equator. The northern hemisphere is tilted away from the sun, and so it's cooler. If I let it keep going, again, you see we're going into spring, temperatures starting to rise, into summer. Now, one thing that I want you to also notice is what's going on with this angle here. And this is the key. This is the whole key to the whole shebang. Why we have the seasons is this right here. The angle of the sun when it hits the ground. The more direct the angle, the warmer it's going to be. And as we get to winter, you can see the angle of the sunlight gets lower and lower in the sky. And if I pause this or stop it, right here, the sun, if you notice, the sun is really low in the sky. When I move around to summertime, where the Earth is tilted towards the sun is, if I go back, the sun is much higher in the sky. And because it's higher in the sky, this angle is higher. And what that means is we get more direct sunlight. So the sunlight is more concentrated on the ground. Lower it is to the ground, the more spread out the actual rays are, and so the less heating you get. So there we go. It's lower in the sky in the wintertime, and that gives us cooler temperatures. That's really the main reason why we have the seasons. There's a small part of it that has to do with the number of daylight hours as well, but as we'll see when we talk about the North Pole, it's not a huge reason. Now, what I want you to make a prediction of is what's going to happen to the temperatures in summer and winter when we go to a more tilted angle. So I'm going to tilt this even more. So if you could pause this and just take a second to have students make a prediction, I'd like you to do that. So we're back. I'm going to change this to the angle at which we're much steeper. So let's say we're at 68 degrees. Everybody wants me to turn it to 90, so let's turn it to 90. Why not? So we're tilted all the way on our sides. And let's see if your predictions prove true. It's when in the winter time here now, it was really cold. The sun wasn't even over the horizon at all. And now the sun is out all day long because all we're doing is spinning on our side. We're directly facing the sun. The angle of sunlight was really high, and so we get higher temperatures, colder temperatures because there's no sunlight at all. It's nighttime, 24 hours a day. Really cold because there's no sun, and here we go. Sun's at a really high angle, and that makes it super hot, uninhabitable, really. So we'd have 6 months of scorching weather and 6 months of freezing weather. And this is part of the reason why in the wintertime, the North Pole is so cold, because here we are. If we go back to just what the Earth's tilt is, it is the North Pole doesn't get any sunlight, and I'll show you that in the next animation. So then the next question on there, as I go through this, where we're at 23.5 degrees, what season, if we look at the sun angle, what season is that at the highest? So you should be able to answer that at this point. We can see here we are in summer, the angle is the highest. We're going into autumn, and it gets to the lowest there. And how does this angle affect the temperature? Well, when the angle is really low, that's the next question. When the angle is really low, the temperatures are going to be colder because the heat is spread out over a wider area. And if we are at a higher angle, the sunlight's more concentrated, so it heats up more. So that's question number 8. For question number 9, I want you to pay attention to how long the sun is out. So how long we're in night and how long we're in day here. And we'll play through this and see if you can, I'll do it slow so that you can sort of walk through. It's kind of slow. Let's see if I can do this a little faster. Yeah. Sorry if this is not working out the way I wanted it to. I thought this would work out to be a good question. But really, what you'll see here, the sun comes up over the horizon quickly. Zoom. It's up and then it's down in the wintertime. In the summer, if you look, here's the spring, now we're in the summer. It comes up around, if I pause it and I go back, it's the sun in the summertime. If I move this back here and I play in that, we watch for it to come up. It rises early. I'm going backwards here now, sorry. I was wondering why it was rising in the west and setting in the east. So it's up for a long part of the day. It sets. Here it says it's setting at 7 o'clock. Really, it sets in our area around 8 or 9 o'clock, sometimes 10 if you're up further north. But that changes throughout the year. And that's one of the things that you probably saw, I think that you guys did, time in terms of places around the world where they have different times for different seasons. So the longer days are happening in the summer. In the wintertime, this is just something that you should remember really just from your own experience. If you remember, you go to school, you wake up, it's dark, you leave school and it gets dark around 4 o'clock, 5 o'clock, it's pitch black, and now it's still light out, around 6 o'clock. It's going to start, as we're getting into winter, it's going to start getting later and later, or earlier and earlier that the sun's setting and the sun rising later and later. So that's that animation. What I would like to also show you is this one, and if I can move this over. So this is just another way to look at this, and if we go throughout the year, this is sort of a ability to see the side view and see where the sun is shining on the earth. And I tried to show you this in the first video, but if we look in June, June 21st, the summer solstice, the longest day of the year, you can see the sun is shining, the earth is tilted towards the sun, and here's the Arctic Circle, this red line. And if you look, if you were up here, you would have 24 hours of daylight. So the sun would just go around and around in a circle all day long. For if you're at the North Pole, it'd be 6 months that it does that. As we move throughout the year, that shadow line, you can see that shadow line changes. And September 21st, the equinox means equal, nox means night, it's Latin. So equal day, equal night. Everywhere on Earth gets 12 hours a day and 12 hours a night. That circle that represents where you would be circling around on the Earth is split equally day and night. So there's 12 hours a day, 12 hours a night. If I switch this and move it over to December, now we have sort of just the opposite. Here's the winter solstice. Sorry, where was it there? December solstice. And you can see 24 hours of darkness. So that's that's part of the reason why in the wintertime it's really, really cold up north. Part of it. Not the whole thing, because you would think that if just the number of daylight hours was mattered in terms of what your temperature was, then you would have the hottest place on earth should be up here if that was the only thing. But it's not. As we saw in the last animation, it's all about the angle of the sun. So here, even though you get 24 hours of daylight, the angle of the sun is still pretty low on the horizon. So it doesn't get very direct sunlight. So as this as we're going around, you can see here we get lower angle of insolation or lower angle of sunlight. The southern hemisphere gets the higher angle, so it's their summer, our winter, and then we move our way back to spring, where we have again 12 hours a day, 12 hours a night, all the way around the world, and then back here to summer, where we have summer and they have winter. The best way to find, if you have to label a diagram, just as a side note here at the end, if you have to label a diagram with the seasons, the best way to do it is to find where summer is or winter. And summer is always where the North Pole is tilted towards the sun. Once you have that, usually they tell you which direction the Earth is revolving, and we know that fall comes after summer, winter comes after fall, and spring comes after winter. And so that's the best way to find those. Hope that helped, and go over the. I'd like to take a minute and do your conclusion. Do the best job you can trying to come up with a good conclusion that talks about the angle of the sun, tilt of the Earth, and revolution of the Earth around the sun to show why we have seasons.